Welcome to Module 201A on second period math applications. Before you really get into this, I strongly recommend that you go back over your first year notes and remember some of the things that we discussed in first year. It's going to help you remind yourself of what you need to do, and it's going to give you a heads up on some of the things we're going to talk about here. This module has 9 different objectives that we're going to split into 6 videos. The first video is going to deal with objectives 1, 2, and 3 on order of operations, transposing, and squares and square roots. The second video will deal with scientific notation and SI prefixes. The third video will deal with Pythagorean theorem. Number 4 will deal with trigonometry. Number 5 will be the addition of phasors. And lastly, video number 6 will be on objective number 9 of ratios and proportions. So let's get started with objectives 1, 2, and 3 in video 1. First of all, here's a bit of a review from first year, being order of operations. If you remember, anytime that we have a formula, we have to follow a certain standard in order to solve that formula. And that standard is the order of operations. We use the acronym BEDMAS to remember how to organize our formulas. First, we solve anything that's inside a bracket. Then we will solve anything that has an exponent, and then we'll solve anything that has a division, and then multiplication. Keep in mind, we can do multiplication first. The important part about that is to make sure that we are solving the equation from left to right as we would read a book. Then our last two are addition and subtraction, and which also can be reversed if we need to. As long as we're solving the equation from left to right, when it comes to the division and multiplication or the addition and subtraction, we can do either one first. Let's walk through solving our first equation. Here we have 6 plus the bracket of 2 times 3 squared minus 8 divided by 2. If we remembered BEDMAS, the first thing we need to deal with is the B, which is the bracket, which means that we're going to be dealing with this 2 times 3. What we want to do is solve that portion, rewrite our formula to simplify it, and then continue on with BEDMAS. So our formula becomes 6 plus 6 squared minus 8 divided by 2. So we took that 2 times 3, converted it into a 6, and put that into the formula. The second part of BEDMAS is exponents. So the 6 squared is going to be the next thing that we deal with. Once again, solve that part, rewrite the formula. So our formula now becomes 6 plus 36 minus 8 divided by 2. The next part of BEDMAS is division. Since we have one division in here, this is what we're going to do next, and we need to solve that and simplify. 6 plus 36 minus 4. Now our last two is addition and subtraction, and as we mentioned before, solve the equation going from left to right. So it's 6 plus 36 minus 4 equals 38. Now that we've broken down our first equation, let's look at the next one. This one looks a little bit more complicated, but it really isn't. In this case, we have two sets of brackets, both on either side of the divide sign. In our first set of brackets, we actually have brackets inside the brackets. Now, anytime that this happens, we still have to follow BEDMAS. So we take that first set of brackets, apply BEDMAS to that until we come down and solve all that. And then we can move on to the next set of brackets, apply BEDMAS to that, and continue on again. So when we look at our first set of brackets, we have a set of brackets inside that, and that's what we need to solve first. We need to take care of this 6 plus 4. Normally in BEDMAS, the addition is way almost at the bottom, but since this is inside a bracket, math tells us to take care of this first. This converts our formula to 10 times 10 on that first set of brackets. As I mentioned before, I'm going to keep solving that first set of brackets before I move across to the other side. So 10 times 10 is the next thing we want to solve, and that becomes 100. So now we simplified our formula to say it's 100 divided by a bracket 2 cubed minus 7 bracket squared. So let's take care of that second set of brackets first. If we remember BEDMAS, first we have brackets, then we have exponents. So we take care of the exponent inside the bracket first. So this is what we have to deal with, 2 cubed. So we simplify that. 2 cubed is 8. So now inside the bracket we have 8 minus 7, and then that sum is now squared. So we take care of this 8 minus 7, which gives us 1. Our new formula becomes 100 divided by 1 squared. So we take care of this 1 squared, it just is 1. So 100 divided by 1 happens to be 100. So even though this looks more complicated, if we follow BEDMAS rules and apply BEDMAS inside the brackets themselves, it's not really that hard to get all the way through from one to the other. Now that we've done two examples together, here's the third example, and I'm going to have you do this on your own. So once again, we have brackets inside brackets, so we need to solve all that first. Just follow BEDMAS through line by line, making sure you're solving everything in the order that it says to. Pause the video, solve this equation, and when you're ready, continue through, and I'll show you what my solution was for it. Okay, are you ready for my solution? Here's what it looks like when it's all done. So you start with that first bracket. 18 divided by 2 is 9. So I simplify that to be 9 minus 5. On the other side, I can look at the second set of brackets, and I did this in two steps here in one line. So I still have the 6 squared, but now I took the 3 squared and made that into a 9. So now I have 9 minus 5 times 6 squared divided by 9 times 4. So let's deal with that first bracket again. I simplified the 9 minus 5 down to a 4. I took the second set of brackets, I took the 9 times 4 and simplified that down to 36. So now I can go on to the next step. So I have 4 times 6 squared divided by 36. So since the 6 squared divided by 36 is inside the bracket, deal with the 6 squared first, which turns it to 36. So 4 times 36 divided by 36 is the same thing as 4 times 1, which means our answer is 4. Did you get it? I hope so. So that is BEDMAS. The next thing we're going to look at is a very valuable skill, and hopefully you paid attention in first year and you nailed this. Transposing equations. This is a skill that you're going to use for the rest of your school career, and it comes in so handy. If you can transpose an equation properly, you can actually take one equation and make 3 equations from it. It's a lot less to memorize, isn't it? As long as you understand how to do it properly. So just a few things. The purpose of a formula: defines a relationship, provides predictability, and relies on patterns. Another way to think of it is that a formula is just a numerical way to express what a theory is. So if we know what the theory is, we can predict what the formula is going to be, and the formula should be there to prove that the theory is correct. The purpose of transposing is to be able to use math logic to make sure that we can rearrange any formula so we can solve for any one of those items inside that formula. So the goal of transposing is to get the desired value by itself on one side of the equation and properly move everything else that we don't want to solve for to the other side. And like I said, this is such a valuable skill. I'm going to make sure you guys have a worksheet for this. Make sure you go through it all, and if you're not understanding how some of these formulas transpose, make sure you get in touch with me, because I really want you to understand this. So, transposing rules. It's called an equation for a reason. It's an equation because both sides must be balanced and they must equal out. That means whatever we do to one side, we have to be making sure we do the exact same thing in the exact same way to the other side. And anywhere that we can group things, it's going to be to our advantage. So if we have to divide out the entire bottom side of an equation, for example, we can group that together and move all those variables at the same time. And of course, the most important thing about transposing is to understand what the opposite functions are so that we can use those opposite functions to be able to move our variables around properly. Speaking of opposite functions, this is what we should understand to be the opposites. Plus is the opposite of minus and vice versa. Multiplication is the opposite of division and vice versa. And squares are opposites of square roots and vice versa. So anytime we have a square, if we apply a square root to it, we'll get rid of a square. Anytime that we have an addition, if we apply a subtraction to it, we'll get rid of the addition. And same thing for multiplication and division. Here is a formula that you should know quite well. This is Ohm's law. E is equal to I times R. Now, when we look at this formula and we want to solve for one of the terms that is not E, then we have to transpose this. So right now, this formula as it sits will allow you to solve for the variable E. But what if we want to solve for either I or R? Let's solve for I first. Now I is multiplied by R. So in order to get rid of the R, we have to divide the R. But once again, whatever we do to one side of the equation, we must do to the other side. So if I take the I times R and divide that entire side by R, I had to divide the entire other side by r as well. What that does is that gets rid of the r on the one side. Remember that division and multiplication are opposites. So if I go I times r divided by r is nullified. It's gone. What we're left with is our formula I is equal to E over R. So this is transposing. It's basically taking a value that we want and we isolate that by getting rid of everything else that's on the same side. And in order to do that, we have to do the opposite function of whatever that math is. Another way we can do this is with circle charts. Now, anytime that we have a formula that is one value is equal to two other values multiplied, we can put them into circle charts. So we do this quite often in first year with Ohm's law. So if we have E over I times R, then whatever number that we use in our circle charts, if we want to solve for E, we cover that up with our hands, and then we can see our formula I times R. If we wish to solve for I, we cover up the I with our hand, we have E over R, and the same thing for R, we cover up the R with our hand, and we have E over I. This is a very simple and graphic way to do transpositions easily. It doesn't work with everything, but anytime that you have three terms and two of those terms are being multiplied to equal the third one, it's great. Now, if you ever have a question about whether or not you transpose your equations properly, just substitute in some numbers that are easy for you and you know are going to be correct, like 6 is equal to 3 times 2. If E is equal to 6, I is equal to 3, R is equal to 2, hey, that works. And then no matter how I manipulate this formula, if I keep those three numbers representing the three different components, the math should work every time. If it doesn't, then you've made a mistake. So use substitutions like simple numbers in order to check your formulas. So here's our next formula. It's our area formula, which is A is equal to pi times r squared. Remember that things like multiplication can be shown different ways, and if there is no function between two variables, that is multiplication. It just simplifies how our formulas look, especially if we're using variables like x's. Then maybe eliminating that time symbol will reduce the confusion with an x. So here we have pi r squared, and we're going to solve for r. Now pi is a firm number. We all know it's 3.1415, yada, yada, yada. It goes on forever. So we're not going to solve for pi. Pi is a variable that we already know. But we need to solve for the r squared. Particularly, we want to isolate the r. So we're going to have to deal with that square root. But that's going to be the last step that we do. In order to deal with the r squared, what we want to do is kind of isolate the r squared completely from the pi. And using brackets is another way of showing multiplication, and it also groups those two terms, the r and the squared, so we can move them around at will. However, since we have pi times r squared, we have to do the opposite function of the times, which is, of course, divide. So we're going to divide both sides by pi, just like we did before with the Ohm's law. What that does, it eliminates the pi sign, and we're left with r squared is equal to a over pi. But that's not what we're looking for. We're looking for r. We're not looking for r squared. So the opposite function of a square is a square root. Now here's where it gets really important to group your terms. What I want to do is I want to group that entire second side, the a over pi, that has to be grouped together. Because when I do a square root over r squared, that'll get rid of the square for me. But I need to do the square root over the calculation of a over pi. All right, I can't just square root a and I can't square root pi. I need to square root the calculation of a over pi as a group. So make sure you group that second side. Our result is r is equal to the square root of a divided by pi. So it's very important. Use your grouping in a term like this to make sure that that square root is going to cover the entire secondary side of the equation. This is called Pythagorean's theorem and is one formula that we use consistently throughout the entirety of theory in second year. So you are going to be very good at this formula, so you might as well be very good at transposing this formula right away. This particular one tends to confuse a lot of people because there's squares everywhere and people are confused about how to deal with those squares. So we're going to show you how to do this, and we're going to show you something else that you need to know when solving an equation such as this. The first thing is leave the squares where they are. We'll deal with the squares at the very end of the formula and not before then. That's very important. So we're going to treat each variable with its square as a unit. The first thing we need to do is if we're going to solve for a, we have to get rid of that b squared. So we want to get a squared all by itself, and we want to get rid of the b squared. Of course, that's an addition sign. Therefore, in order to do that, we have to do a subtraction. So we're going to go a squared plus b squared minus b squared, which is going to get rid of that b squared. What we do to one side, we have to do to the other side, but it's even more important than that. See how I subtracted b squared from that second side? I have to make sure I do the exact same thing in the exact same way on the other side of the equation, because c squared minus b squared is really different than b squared minus c squared. And if you think about it, if I'm going to put numbers into this, if I had 25 minus 9, that'd be a whole lot different than 9 minus 25, wouldn't it? So we have to make sure that anytime we do a subtraction on one side, we do the exact same subtraction in the exact same order on the other side. Otherwise, things aren't going to work. After we've done that, we can continue on to simplify our formula. We now see that a squared is equal to c squared minus b squared. But we're solving for a, so we still need to get rid of that square. Just like we did before, we want to treat that entire second side as a unit. And we want to square root that entire second side. So put some brackets around that. This way, it's grouped together. We know that's all going to be a unit. I have to solve the c squared minus b squared before I can do anything else because it's inside brackets and I follow BEDMAS. In order to get rid of the square on the a, I have to square root the a squared, and I also have to square root the total of c squared minus b squared. So that entire secondary side is square rooted, not just each one individually. So preserve the c squared minus b squared by putting brackets around it. And what our solution is a is equal to the square root of c squared minus b squared. Most people, when they get this one wrong, they will square root the c squared, and then they will square root the b squared, and then you end up with c minus b equals a, which is completely incorrect. You have to make sure you group that term on the second side. All right. I'm going to let you guys solve for z. So here we have x squared is equal to y plus z divided by 2. So figure out what you need to do, what are the steps going to be, how do I get rid of things, and then pause the video, solve this, and then when you resume the video, we'll solve it together. Okay, let's look at the solution. We have x squared is equal to y plus z in brackets divided by 2. In order to get rid of divide by 2, I have to multiply by 2, and I do that to both sides. So this is x squared times 2 is equal to y plus z divided by 2 times 2. So the divide by 2 times 2 eliminates. Our formula gets simplified to x squared times 2 is equal to y plus z. So let's deal with the x squared times 2. X squared times 2, we can rearrange that to say 2x squared, and it's the exact same thing. Remember that when we don't have a variable between numbers, it still means multiplication. So that's the same thing. All we've done is rearranged it a little bit. So 2x squared is equal to y plus z. Next, since we're solving for z, we have to subtract the y, and as we did before, we have to take that subtracting y to both sides the exact same way. So y plus z minus y simplifies that side to z. Z now equals 2x squared minus y. Now the 2x squared thing may have tripped you up a little bit. You might have x squared times 2 minus y. That is also fine. That's also acceptable. I'm just showing you a different way to do this. But this is what a solution for z should look like. Hopefully you got transposing really well, and you can do the worksheets that come along inside Blackboard to make sure that you get lots and lots of practice. As I said, very important that you guys know that particular trick. It's going to save you a lot of time and effort memorizing things in the future. Let's move on to squares and square roots. And with transposing, we've already kind of gotten a little bit of knowledge with squares and square roots. So a square is any time I take a number and multiply it by itself. Like 2 squared is 2 times 2, which is 4. 5 squared, which is 5 times 5, it's 25. 10 squared is 10 times 10, which is 100. So a square is just a simple way to say that we're going to multiply a number by ourselves. Now, a square root is the opposite function of a square. It's finding what number multiplied itself equals the number that you started with. So when we use transposing, we have to remember to group our terms so that when we square root one side, we square root the entirety of the other side, or if we were to square one side, we square the entirety of the other side. Make sure that we always keep our equations equal on both sides. That's end of part 1. Make sure you go through this, make sure you go through your module as well, and you fully understand both bedmass, transposing equations, and also, since we deal with squares and square roots so much in second year, make sure you understand the concepts of the square and square root. Go to Blackboard, do the worksheet and the knowledge check, and then you can continue on to part 2.